Have you ever wondered how cities in Pakistan are economically connected through price patterns? Welcome to our Discrete Structures project, where we uncover these hidden relationships using network theory and mathematical modeling. My name is Abdul Moid, and with my teammates Mohammad Sarim and Mohammad Zulkarnain, we will be showing you how we transform raw data prices into meaningful economic insights. So we started with monthly consumer price index data from the Pakistan Bureau of Statistics, covering multiple cities and years. But raw data alone isn't enough. We we organize products into seven meaningful categories like food staples, utilities, and transportation, each weighted by economic importance. For example, food gets 25% weight, while clothing gets 5%. So it reflects real world spending patterns and implications of how real world interactions and expenditures are made. So basically, our project's goal and approach was very simple, but it was powerful. If two cities have similar price movements across products, they're likely to be connected economically. So we used cosine similarity to measure this alignment and built temporal networks to see how these connections evolve over time. So this isn't just data analysis, it's uncovering the invisible economic web that is connecting Pakistani cities. Now let me hand over to Mohammad Sarim, who will explain the mathematical engine behind our analysis.
So, imagine each city has a price personality, a vector showing how prices move across different products. Cosine similarity measures how aligned these personalities are. For example, let's consider if Karachi and Lahore have identical price movements, their similarity is one, and if the movement is completely in opposite direction, the similarity is zero. We normalize prices first to focus on patterns, not absolute values. But when the cities similar but when the cities are similar enough to be connected, we set for that reason we set a threshold of zero point 0.7, meaning which meaning cities need 70% price pattern alignment to form an edge. These creates meaningful networks, and we have taken in our account the different types of different level of threshold. zero point 0.7, which is a moderate threshold. zero point 0.5, which includes weak connections too, because the threshold is much lower, and zero point 0.8, which only have the strong connections. Now, which cities matter most in these networks? We use four centrality measures: degree counts, direct connections, like how many friends you have. Closeness measures how quickly price information spreads from a city. Betweenness identifies bridge cities that connect different regions. Eigenvector finds cities connected to other important cities. It's about having influential friends. But networks change over time. We compare networks across years using subset rotations. This is relations. If all connections of 2023 exist in 2024, we says that 2023 is a subset of 2024. This creates a partial order that we visualize using hash diagrams, showing how economic integration evolves. Now, talking about the implementations, Zulkarnain will tell you about that.
Okay, so I'll be talking about how we transform the raw Excel data into analytical insights. So the first thing we did was that we cleaned and categorized each and everything. Like if something contains, is some sort of product contains wheat or rice, it will go to the food staples category. We handle the missing prices by using category averages, ensuring no city is excluded due to the data gaps. Our code creates city by product matrices, which normalizes to compare the patterns and not magnitudes. Uh, it then computes the cosine similarities and talking about the results. They were like some sort of beautiful heat maps where bright yellow shows strong connections and dark red shows the weak ones. Each cell represents how two cities' price personalities align, but which centrality measures matter the most. So, talking about that, I'd say that for that we implemented three approaches. The equal weighting, which gives all mayors 25% importance, the correlation based reduces the weights for redundant mayors. Like if degree and betweenness always agree, they share importance, and then the entropy based favors mayor that mostly across cities, capturing the unique information. And then talking about the Hasse implementations, like for temporal analysis, we check if the edges from earlier years persist in later years, creating our subset relations when no clear subset exists. We order by network density, showing economic integration progression. Our enhanced diagrams color code relationship types, as I've discussed earlier, and include the network statistics for complete context. Now, talking about the visualization and the key findings, Abdul Mohit will be explaining those things to you.
Mohit, your mic is off.
Now we're going to be talking about the visualizations of how basically all our work has resulted into what. So, Zulkarnain, can you open the heat maps folder, please? Yeah. Okay. So, the bright diagonals show cities that are more similar to themselves. But the real story is in the patterns. Major cities like Karachi and Lahore show widespread similarity, while smaller cities cluster regionally. Each category tells a different story. Food shows nationwide patterns, while utilities reveal infrastructure dependent connections. Can you open the network graphs, please? Yes, yeah. Okay, so our network graphs make abstract connections tangible. Karachi sits at the center with connections to other cities, and that's a high degree centrality. Cities like Quetta that connect different colored clusters, that's high betweenness. The node sizes show influence, like larger nodes are more central to Pakistan's economic network. And basically, our comparison charts reveal fascinating insights about city influence. Under equal weighting, Karachi consistently dominates across all years. But when we use correlation-based weighting, cities like Quetta and Peshawar rise significantly, showing that they play unique bridging roles in the economic network that isn't captured by simple connection counts. So this demonstrates how different mathematical perspectives can reveal different aspects of economic importance. The hash diagrams, they tell a story of economic integration over time. So when we see arrows from earlier to later years, it means economic connections are growing and persisting. Some categories like food show stable patterns year after year, while utilities network evolve dramatically as infrastructure develops. These temporal patterns help us to understand Pakistan's economic transformation at a granular level. So I'm going to be handing over to Muhammad Salim now, who's going to be telling you about the interpretation and economic insights of all of this.
So now let's talk about what it all means. Karachi's consistent top ranking across all weighting schemes and years confirm its role as Pakistan's undisputed economic hub. But more importantly, our analysis shows why is this. Karachi maintains strong connection across product categories, serves as bridge between different economic regions, and influences prices nationwide. This isn't just about size; it's about strategic economic positioning. Now let's talk about regional specialization patterns. Our analysis reveals fascinating regional specializations. Quetta emerges as crucial bridge connecting western regions with central economic hubs, a role that becomes especially clear under correlation-based weightings. Peshawar shows strong regional influence in north, while Lahore demonstrates balanced centrality across multiple mayors. Each major city plays a distinct economic role in Pakistan's national network. Now, let's talk about policy implications. These findings have real world implications. Cities with high betweenness centrality like Quetta could be strategic location for infrastructure investment to enhance national economic integration. The category specific patterns help target commodity policies. Food networks need different approaches than utilities. Our mathematical framework provides evidence based guidance for regional development planning. Now, talking about the conclusion and mathematical contributions, Zulkarnain will tell you about those.
Okay, so talking about the conclusions, our project successfully determines how discrete mathematics can solve real-world economic problems. We've implemented relations to define city connections. We use graph theory to model economic networks, applied partial orders to track temporal evolution, and developed sophisticated weighting schemes to measure influence. So we can conclude that this isn't just theory, it's mathematics in action. We introduced several innovations, year-wise aggregation for cleaner temporal analysis. We enhanced Hasse diagrams with multiple relation types and sophisticated weighting that adapts to data characteristics. And most importantly, we created a reproducible framework that can analyze economic networks for any country or region using similar data. So, in conclusion, we've uncovered the invisible economic web connecting Pakistani cities and shown how discrete mathematics provides powerful tools for understanding the spatial economic relationships. Our analysis, including all the our complete analysis, including all the visualizations and the code, basically demonstrates the practical value of mathematical modeling in economics. And while concluding, I would thank you all for taking your giving your time and watching our presentation. Thank you.